So we have this 7-foot beam right here, and it's made from these individual red rods, and each rod's a foot long, so this is a 7-foot beam, right? There's 1 foot, 2 foot, 3, 4, 5, 6, 7 feet long. They want to know which of these formulas can help represent the relationship between the length and the number of rods are. So I might begin this with my own investigation, where I notice when there's a 1-foot rod along here, how many red rods make that 1 foot in length? Well, let's mark this down, length and rods, right? And rods depend on the length of your beam. So notice with the 1 foot we have 3 beams, 1, 2, and 3. What about a 2 foot, and then a 3 foot, and a 4 foot, right? Well, with a 2 foot beam, we have 1, 2, 3, 4 beams added on to the 3 before it. So it's 3 plus 4, right, or 7. And then you can see that'll happen every time. With a 3-foot beam, we have another 1, 2, 3, 4 beams added to make 11 rods total. With a 4-foot beam, you have another 4, 1, 2, 3, 4 beams added to make 15. So our slope, in a sense, is for every 1 in length, we increase the rod by 4. So it's 4 times L, right? But what about the y-intercept? Well, if we realize this is a positive correlation, right, that means as the length increases, the number of rods increase by 3, but the reverse is true. As my length decreases by 1, the amount of rods decrease by 4. Now the y-intercept happens when the length is 0. So you have to imagine if I had a 0 length, how many rods would I have? Well, I go back 1 and subtract 4, right, from 3, because it's always the rods are always decreasing by 4 whenever my length decreases by 1. Right, so here, decrease by 1 from 1 to 0, my rods go from 3 to -1, and that's my y-intercept. So there's my formula right there, and that's my reasoning behind it. But there are other ways to express the same idea. For example, this formula actually works as well. Kind of interesting idea. I didn't perceive it this way, but we can read what it says. The amount of rods equals the length. Well, this will be the length down here. Notice the length for the entire thing is 7. 1, 2, 3, 4, 5, 6, 7. Plus length minus 1. Where's that coming from? Well, the top portion is the same as the top, except it's 1 less beam. So it's L minus 1. And then plus 2L. Now 2L is just for each foot, each length, there's these 1, 2 rods, different color, 1, 2 rods along the way. 1, 2. The color's terrible, sorry. I'll use red. Right, so we have length on the bottom plus length minus 1, because the length on the top will always be 1 less than the bottom. You can count here at 7 along the bottom, 6 along the top, and then you have these 2 extra rods for every foot. So that thinking might lead to this formula. Algebraically, we can simplify it though. L plus, right, L minus 1 plus 2L. Well, we have L plus L minus 1 plus 2L. I'll use a script L here. So 1, 2 L's plus 2 more is 4L minus 1. These, you can see that algebraically these two things are equivalent, just the thinking behind them are different. The last one that works is not this one. It's not 3, right? It doesn't work at all, so I'm not going to evaluate the thinking there. But this one works as well. This is kind of like our approach earlier. It's saying, listen, you know, you've got the 3 rods that you start with for the first foot. But then, every foot beyond that, you add 4 rods. And you can tell that in the formula, R equals 4 times L minus 1 plus 3. If you plugged in L equals 1 here, what's going to happen? Well, then the rods equal 4 times 1 minus 1, or L minus 1, plus 3. So 4 times 1 minus 1, or 4 times 0, that's just 0 plus 3. So that works, right? The rods give you 3 rods. This formula works for 1 foot. And the thinking is you wanted to get 3 at 1 foot because that's how many rods there are. So you subtract 1 from the length to get the 0, and then it's 4 past that. So the rods could equal, right, 4 times L minus 1 plus 3. If the length equals 2, let's just see how this formula works. So that would equal 4 times 2 minus 1 plus 3. So 2 minus 1 is 1, so it's 1 group of 4 plus 3. That's the number of rods for 2 feet, which is 7. Now if we simplify this formula, we get the same thing as before, right? Let's just do that really quickly. And this, again, it's just a different way of thinking about the same setup, plus 3. So 4 times L is 4L, minus 1 times 4 is minus 4, plus 3, minus 4 plus 3 is minus 1. So it's 4L minus 1, which is exactly what we got before. So these three are equivalent. It's just important to realize you can approach the same problem in different ways. Thanks.